3, 2, 1. We are going live. So, okay, let's go.
Здравствуйте, дорогие коллеги. Приветствуем всех, кто присоединился на нашу открытую лекцию от компании Chainlink. И, соответственно, здравствуйте, дорогие коллеги. Приветствуем всех, кто присоединился на нашу открытую лекцию. Татьяна, мне кажется, вам нужно пока выключить звук, потому что ловятся, мои слова. От компании Chainlink. И, соответственно, здравствуйте, дорогие коллеги. Приветствуем всех, кто присоединился на нашу открытую... Татьяна, мне кажется, вам нужно... выключите у себя звук, пожалуйста, пока, потому что что-то я слышу себя. Мои слова. От компании Chainlink. Так, сейчас, сейчас лучше, видимо, там пошла обратная связь, такое бывает. Еще раз приветствуем всех, кто присоединился на открытую лекцию от компании Chainlink, которая устраивает магистратуру по блокчейну МФТИ. Нам очень лестно, что такая известная компания согласилась провести свою лекцию, и в том числе это первое подобное мероприятие, которое проводится на территории России. И я хотел бы передать слово представителям компании Chainlink. Это Татьяна и Хари Папакарису. Надеюсь, я назвал вашу фамилию совершенно правильно. Да, спасибо большое. Татьяна, тогда передаю вам слово. Надеюсь, вы чуть-чуть больше расскажете, что же будет сегодня происходить, расскажете про вас. А я, соответственно, пока отключаю звук, чтобы не было никаких помех. Извините, хочу сразу сказать, что вы можете задавать свои вопросы. Трансляция идет в Zoom и на YouTube. Если вы смотрите трансляцию в Zoom, то вы можете писать ваши вопросы, которые у вас появляются во время лекции, в общий чат. Также вы можете писать их лично мне или Татьяне. Мы их обязательно озвучим. И лекция у нас будет состоять из 2 блоков. Соответственно, после каждого блока вы можете услышать ответ на свои вопросы. Все, Татьяна, передаю вам слово.
Здравствуйте, меня зовут Татьяна, я адвокат Chainlink в России для русскоязычного сообщества, которое выходит далеко за пределы России. Это наше первое мероприятие для русскоязычного сообщества, поэтому добро пожаловать и большое спасибо за проявленный интерес. Особенно рада, что это первое мероприятие сразу с таким большим и важным университетом, институтом, как физтех. Во-первых, здравствуйте и спасибо за ваше участие. Chainlink – это огромная компания с очень серьезными технологиями для блокчейна. Хари Папакарису расскажет о них подробно. Я просто хотела вас всех поприветствовать, рассказать о Chainlink в 2 словах. Также мы ищем новых адвокатов Chainlink в России. Если вы заинтересованы, пожалуйста, присоединяйтесь к нашим каналам в Телеграме, на Дискорде. Я позже поделюсь всеми ссылками. И представлю вам Хари Папакарису, который присоединяется к нам из Австралии. Он девелопер в Chainlink Labs. Он расскажет сегодня про проблемы оракулов, про Chainlink технологии для DeFi. И я сейчас быстро проговорю, в принципе, то же самое на английском. So, a quick brief introduction in English. This is the first Chainlink community gathering for Russian community, and it's a very famous university, Moscow Institute of Physics and Technology. And we're giving this lecture for them exclusively, and we're extremely proud to have this big introduction with this famous institute. Hari Pupakariso is a Chainlink developer. He works at Chainlink Labs, and he will walk us through the Oracle problem in blockchain, which Chainlink solves, as well as our technologies for DeFi in particular. Going forward, we'll have more events in Russia, in person and online. So stay tuned, and Harry, over to you. Take it away.
Awesome. Thanks, Tatiana and Vladimir. Can you guys hear me okay?
Yes.
Yes, it's fine.
Okay, I'll just share my screen. Hopefully everyone can see that. Okay, thanks. So yes, my name is Harry Papakarisiou. I'm a developer advocate at Chainlink Labs, and we work on what's called the Chainlink project or the Chainlink network. And today we're going to be going through quite a few things, so there's quite a lot to get through. We're going to talk a little bit about digital agreements and what we call cryptographic truth. Then we'll discuss the Oracle problem and Chainlink in general. And then we'll talk about some of the solutions that Chainlink offers, such as price feeds, accessing APIs, random numbers in blockchain-based systems, and then Chainlink keepers for decentralized off-chain compute. And then we'll close things off by talking about where can you go to learn more. So the way this works is the lecture's kind of split into two parts. I think the first part's more presenting, and the second part is presenting with hopefully some quick code demos if there's time. So if anyone has any questions, feel free to note them down, and we'll stop at the end of each section for questions. So I'm going to try not to speak too fast because I have a tendency to move fast, but if I am going a little bit fast, Tatiana, feel free to interrupt me and let me know. So the first thing that I wanted to talk about here is, why are we here today in this lecture? Why should we care about blockchain? Why should we care about smart contracts? And why should we care about things like oracles? And I just wanted to go through the immense possibilities that these technologies can do for the world, because it's something that's important for us to understand. And in many cases, I think some people, it's larger than what some people may assume. So in today's world, we have what we call digital agreements, right? And these are agreements that underpin many aspects of our lives. So, you have an agreement with your bank, you have agreements with your insurance company, you have agreements with your, video streaming services, whether it's Netflix or Eevee or whatever it is. You have digital agreements with your social media accounts as well, right? And these are what we call just trust us paper promises. And the reason we call them this is because there's no real firm guarantee or commitment that these agreements will be fulfilled, other than a choice or desire to by these companies or conglomerates or, whatever these companies are. So, the bank will basically control whether they give you access to your money and assets. Your video on demand streaming service, whether it's Netflix or some other one, they'll take your money and they'll give you access to their content. The insurance company will decide whether they pay you out if you crash your car. The crypto exchange will decide whether to allow you access to their to your assets, right, that they hold for you. So these are the digital agreements as they exist today, and everyone's used to the world working this way. That we haven't really questioned it, and we haven't really thought there's an alternative. But the fascinating thing is that in 2009 we finally did have an alternative in the form of Bitcoin. And then that's evolved over the years into more complex and feature-rich blockchains, such as Ethereum and other chains that have functionality such as smart contracts. So smart contracts, they're not really smart and they're not really legal contracts either. We tend to think of them as highly secure, tamper-proof digital agreements. So the difference between a traditional digital agreement like the ones I described earlier and a smart contract is that the smart contract obviously runs on this decentralized infrastructure such as a blockchain, right? And because it runs like this, it's enabled us to rethink and change the way in which we execute and enforce these agreements. So the big shift is that the contract execution is no longer done by one of the participants in the digital agreement. It's done by this completely separate decentralized infrastructure that has nothing to do with the participants participating in the agreement, right? So it's no longer the insurance company deciding if you get paid out. It's no longer the social media company deciding if they let you go on and post. So smart contracts are examples of what we call cryptographic truth. So cryptographic truth is the ability to guarantee an outcome based on cryptography and maths and physics. So what you see here in this diagram here is a spectrum that represents the digital agreements that we have today. So on one end of the spectrum, you have, as I described earlier, these just trust us, paper or digital promises where, you have some document somewhere and there's someone that might do something, right? And you hope that they'll do it. And as I said before, there's no guarantee that they'll be fulfilled as expected, because they're relying on someone doing something in the end, right? They're relying on a person or a company to act in good faith. On the other end, you have, as I described earlier, cryptographic truth, which relies just on maths, physics, and cryptography, right? It doesn't rely on a company, it doesn't rely on a person, and it doesn't rely on a brand. So this cryptographic truth model was first introduced in Bitcoin and has since evolved into many more advanced things such as DeFi and then what we call hybrid smart contracts, which I'll explain in a little bit. So here's a modern example of a just trust us, paper, guarantee. So Robinhood is a TradeFi product, a traditional finance product. We don't have access to it in Australia, and I'm not sure about Russia either, but you can basically sign up and trade stocks, US stocks, various stocks. And basically what happened earlier this year is they got in the news because a bunch of people from the internet and Reddit were basically banding together and buying up a certain stock, GameStop, I think it was, and it was causing some hedge funds and big hedge funds to kind of lose a lot of money. And in the end, what happened was that Robinhood actually stopped users from buying that stock, right? So Robinhood said, sorry, everyone, the people that are making money, that usually make money, aren't making money anymore. So we're going to just stop this from happening, right? So it was a good example of a just trust us, paper, guarantee, where basically they said that they were able to do whatever they want, and the end user kind of, lost out in the end. So nothing was forcing Robinhood to fulfill or deliver on their promise other than their desire, right? And they didn't want to, and they didn't. So when you look at examples like this, you can see why smart contracts are strictly superior digital agreements compared to these traditional just trust us, kind of paper promises. And the reason they're superior boils down to 5 different things. So the first one, security, tamper-proofness. So because the smart contract is running on this highly secure decentralized infrastructure, it can't be hacked, it can't be gamed, it can't be influenced, it can't be bribed, blackmailed, it has no political affiliation, it's completely decentralized. 2, guaranteed execution. Once again, because the smart contract is running on this decentralized infrastructure, you're always going to have guaranteed execution. There's not going to be a scenario like payment processes and things where the blockchain will go down for a few hours or a few days. 3, transparency. So traditional digital agreements usually hide details from users and other systems, and this has led to issues such as the 2008 financial crisis. With smart contracts, transparency of the agreement and its enforcement is unavoidably built in to the technology. And 4, trust minimization. So we have reduced counterparty risk due to neither party in the digital agreement having control of the execution and enforcement of the agreement. And lastly, efficiency. So all of these things that I explained, security, guaranteed execution, transparency, trust minimization, they can lead to creating more efficient and automated processes that can save businesses cost. Because in the end, having things like trust in a system is an expensive thing to have. So I just wanted to summarize this section of the lecture by saying that cryptographic truth, and in this context, smart contracts specifically, is a strictly better solution than the just trust us model that we have today. So there's no person somewhere that decides what happens. There's maths, there's cryptography, and there's physics. And as long as these 3 things continue to work in the way they work today, which is pretty much the biggest guarantee you'll get in this world, then you're going to get the expected behavior and outcome from your digital agreement, right? So instead of having the possibility of something happening, you have 100% assurance that it will happen. So now that we know why smart contracts are so awesome and superior to their traditional digital counterparts, let's talk about their biggest limitation. So smart contracts are not able to connect to external data or any off-chain resource on their own. So if you're a developer or a student studying here at MIPT, you might ask, well, why can't a smart contract, just make an API call? And the answer is because the blockchain is a deterministic system, right? And if you have an API call as part of a smart contract logic, then you might run into a scenario where certain nodes get a different response from others, or the API call might time out for some nodes, and you're going to lose that determinism that you need. So you might have some nodes get one response, other nodes might get no response. And when that happens, how's the smart contract going to determine how to continue in terms of the execution path and logic? So if making an API call is part of this validation, then you can lose that determinism. So this is defined as the smart contract connectivity problem, not being able to connect to external data, systems, and events. And it limits the usage of smart contracts purely to things that can only be done on chain. When in fact, a lot of the digital agreements that exist today actually require some form of connection to the outside world, whether it's outside systems or data or events. So to interact with the outside world, we need what's called an oracle. An oracle is any device that interacts with the off-chain world to provide data or computation to smart contracts on-chain. So they report the result of that data or off-chain computation on-chain so that the blockchain can stay deterministic. So if there's an API call to find out what the weather is in Moscow today, the smart contract will say to an oracle, reach out to this API and tell me what the weather is in Moscow today. And then the oracle will do the API call and it will report the result back to the smart contract. And then every single node in the blockchain executing that smart contract will get that same input from the oracle. And because they all have that same input, then the smart contract can continue in its execution and we keep that determinism going. So here's where things get a little bit interesting. So using a centralized oracle can actually create a single point of failure for a smart contract and can compromise the overall security of the digital agreement. Because if you've got this highly secure decentralized blockchain, but then you're triggering it with a centralized oracle, then the end-to-end security of an overall system is no better than its weakest point. And in this case, it's going to be the oracle. A hacker or someone trying to influence the system is not going to try attack the blockchain in this case. They're going to attack the single oracle. So how do we get around this problem? So the answer to this is a decentralized oracle network. So, and this is what Chainlink is. So it's a modular decentralized oracle network for getting secure and reliable data on chain and for triggering external computation. So we bring in the data or trigger external computation in a decentralized manner. And by doing this, we solve the problem by extending the decentralization and trust minimization properties that are in a blockchain, and we take them out and we apply them to the data delivery layer and the data source layer as well. So just to try get your head around it visually, here's a small example where we have a number of oracles, or Chainlink oracles in this case, fetching price data from multiple sources. As we can see, there's different prices there, and then they're actually creating a report here with a bunch of different results, and those prices are being aggregated into a single result using an aggregation method, and then that result is posted on chain. So the thing to note here is that not one oracle here, not one single oracle can directly influence the end result by a significant amount. It would take a sufficient number of malicious actors in the oracle network to influence the result in a meaningful way. So by combining on-chain smart contract code with off-chain resources such as oracles, you actually have what we've defined as hybrid smart contracts. So these are smart contracts that rely on existing on-chain smart contract code and combining it with critical off-chain services and computations. So you can kind of think of them as more advanced or more supercharged versions of a normal smart contract. And we're already seeing them, redefine what our industry is about. And we're seeing them already in the form of DeFi and other things today, which we'll go through in a little bit. But I just wanted to bring up this point of how a hybrid smart contract is a normal smart contract or an on-chain code, and combining it with off-chain service such as an Oracle. So in terms of the Chainlink network, we have obviously a Chainlink token, and it's not an ERC20 token, it's an ERC677 token, it's basically an ERC20 with some added functionality. And that added functionality is the ability to call a function along with the transferring of a token or within the same transaction. So with an ERC20, if you wanted to send a token to another address or a contract and then call a function on that contract, you'd have to do it in 2 separate transactions. With the ERC677, you can do it in 1. So the Chainlink token is used as payment for services by Chainlink oracles, because they get paid basically in fees for doing off-chain computation, and also to offset the gas costs for them having to write transactions back on chain. So if you want to reach out to an API and a Chainlink oracle does that for you, it then needs to post a transaction back on chain. So it needs to spend some of the native cryptocurrency of the blockchain to do that. So the Chainlink token offsets that payment as well. So Chainlink is also blockchain agnostic. It's live on Ethereum as well as various other chains. We're live on Polygon, Binance Smart Chain, XDAI, and many more to come, such as Solana. You can integrate with Hyperledger as well. So yeah, I just wanted to mention that it's not just specific to Ethereum. Chainlink is blockchain agnostic, and we're constantly rolling out to various other chains as well. So that's the end of the first part of the lecture. Are there any questions before we move on? I can't see any here.
Harry, there is one question from Nikita. If you scroll up, how much does the stable operating Chainlink node in Ethereum currently earn, or how to assess its profitability?
Oh, that's a tricky one. It depends what the node is doing. So if you're participating in our price feeds, which we're going to get to next, then you're earning specific rewards for sending price data on chain constantly and reliably. If you're running just a node to do API calls or random numbers, then it purely depends on how many requests you get, right? So it's not a constant, stream of income. It's purely a case of, all right, here's my node, everyone. Here's what the details are if you want to use it. And then it's a case of how many people do use it. What is the need for it? So if you want some more specific metrics, I highly recommend reaching out to some of the well-known node operators in the space. And at the end, when we get to some links, you can kind of, you can see where to chase them up in our Discord and things. But node operators such as Link Pool, Link River, they're highly reputable ones, and they're usually very happy to have conversations like this. So they're probably the experts that you'd want to talk to in regards to that information.
Would that be useful information in terms of our upcoming hackathon? That's a good way to practice it.
Yes. So the hackathon's focused on creating decentralized applications that use Chainlink. And once again, we'll get to this later on. The node operator side is kind of basically just a tool to basically use Chainlink, and you don't actually need to run your own node if you don't want to, especially when building your hackathon submission. So when we get to the API calls section soon, I'll go through that in more detail, but you can play around with your own node, and we encourage it as well, but you don't have to if you don't want to, as part of the hackathon.
Thank you, Harry.
Sure. Okay, how are we doing for time? Ooh. Okay, let's talk about data feeds and DeFi now. So, both historically and now, the existing Just Trust Us, paper promises continue to fail society's needs, in certain times. So, whether it's the global financial crisis in 2008, Greek banks denying access to funds in 2015, Cyprian banks taking haircuts off of people's savings a couple of years earlier than that, or even just recently this week, Lebanese banks I've heard are freezing people's savings. So you can see the Just Trust Us set of guarantees when it comes to our financial agreements is flawed. The amazing thing throughout the history of financial agreements is we finally have an alternative to the Just Trust Us model, and that's what DeFi is about. So DeFi, or decentralized finance, is taking any existing financial product today, whether it's lending and borrowing, insurance, the ability to gain exposure and protection from events and things like that, and basically putting them on a blockchain running on smart contracts so that people can perform and use these products with each other in this kind of peer-to-peer scenario without rent-seeking middlemen. And this is a very different way for the world to work. So, for example, how does DeFi work in the Robinhood scenario from earlier? So in DeFi, you have code running on a smart contract. You have a private key with your account. And as long as you control your private key, then no one's going to deny you from having access to your assets, right? And you know that the code in the smart contract is going to execute as designed due to the reasons I discussed earlier, right? So in the Robinhood scenario, if Robinhood was a DeFi protocol, they wouldn't be able to stop users from trading, right? Not unless there was a kill switch codified into the agreement that everyone would know about. So never before in the history of financial agreements could you create this level of guarantee, right? One that just depends on maths, cryptography, and physics. Other than direct control of your assets, one of the other benefits of DeFi is that it's kind of this global permissionless system, right? So this means that someone living in some developing country can get access to financial products and services that they wouldn't usually get, due to their country not providing infrastructure or businesses not wanting to take the risk. So DeFi allows anyone to pursue their economic destiny in this kind of really fair and transparent manner, right? So that's the real value proposition of DeFi. So just quickly, I'll go through a couple of examples of DeFi protocols, ones that use Chainlink as well. So I won't go too deep because we can spend hours on this. So the first one I'll talk about is Aave. So Aave, I'm at aave.com. Aave is a lending and borrowing protocol where you can lend and borrow crypto assets with fixed and variable interest rates. So everything's peer-to-peer and it's controlled by smart contracts and oracles, as we explained earlier. And the loans are fully collateralized. So it's not like getting a home loan or something where a bank or someone takes on the risk of someone repaying the loan. In this case, the loans are fully collateralized. So if you want to borrow 1 ETH worth of crypto, you need to put up more than 1 ETH usually in this case. So in this example here, we're looking at a stable coin, I think, and you need to have, you can borrow up to 0.75 worth of ETH in the principal currency for every 1 ETH worth of collateral. So that's kind of how the protocol maintains that collateralization, sorry. As you can see, there's different borrowing rates, whether it's stable rates or variable. So it's very similar to a traditional lending and borrowing scenario, except it's done peer-to-peer with smart contracts in this kind of trust minimized way. So the next one we'll take a look at is Sushi Swap. So Sushi Swap is an example of a decentralized exchange, and it's actually a type of decentralized exchange called an automated market maker. So basically this means it lets users trade crypto with each other directly without any central authority managing the trades. So instead, it automatically sets prices based on mathematical formulas and processes trades using smart contracts. And in terms of where the funds come from, people submit the funds using what are called liquidity pools, and basically they're large pools of funds where people can lend their crypto and receive rewards for lending it, for putting it on these pools. So in this example, I can say I want to swap 0.001 ETH for maybe a stable coin. And as you can see, if I did that swap, I'll get that amount of stable coins directly and instantly without any kind of centralized exchange or anything handling the trade. And the last one we'll quickly look at is synthetics. So synthetics is an example of a derivatives trading platform. So what that means is it basically gives you exposure to synthetic assets, right? So assets like gold, cryptocurrency, the price of a stock, but they're represented on chain as a token or as a synthetic token, right? So for example, you can buy and sell synthetic versions of the euro dollar without actually having to buy them via traditional, forex methods, right? Because these tokens are pegged to the value of the euro dollar. So that's another example of a DeFi product, very popular one. So how does Chainlink help to enable some of these DeFi protocols? A lot of DeFi protocols need external data. They usually need price data, right? Price of gold, price of Bitcoin, price of oil, etc. So by providing high quality price data on chain, it gives DeFi protocols the data that they need to operate. So this is what our price feeds solution offers. It's a decentralized network of oracles that come together and they basically commit to submitting price data for various assets on chain, right? And they do it in a decentralized manner. And the way they work is there's a decentralized network of anywhere between 9 to 30 something nodes depending on the price pair, and they'll fetch data from multiple professional data providers and aggregators, which fetch data from literally hundreds of exchanges, depending on what the asset is, obviously. And then all that data kind of gets aggregated and then sent on chain to what are called reference contracts, right? So there's a reference contract for the price of Ethereum in USD, there's a reference contract for the price of Bitcoin, etc. And once those updates are sent on chain to the reference contracts, then any consuming DeFi protocol can then use that data. So why is it important to have such high quality, secure and decentralized price data? The reason is basically because of DeFi attacks. So we see attacks happening all the time where DeFi protocols literally lose, millions of dollars due to using centralized oracles or not having sufficient market coverage in the oracles. So that means they just get data from, one exchange or something. But then with DeFi, you can easily game the protocols if they get data from one exchange. So this is why we need to ensure that the data source and data delivery layers of these DeFi protocols is 100% bulletproof. And if you want a really good example discussion on that, I'll post a good article in the chat. So if you can head to data.chain.link to see some of our feeds, the data feeds. So here I'm looking at the feeds on Ethereum mainnet. There's feeds on other chains as well. So for example, the price of Ethereum here, we can come in and have a look. Here's the current answer. Here are all the oracles that submit answers for that price feed. And you can see the history and all the individual updates as well. So the way that the price feeds work is they work on rounds. So each round data is pushed on chain And the way around ends is if the price deviates by more than the specified deviation threshold, which in this case it's set to 0.5%, then an update will be pushed. Or if it hasn't, then if the heartbeat expires, then it will push an update on chain as well. So in this case, if the price didn't deviate by more than 0.5% over the next 50 minutes, then an update would still be pushed. In terms of what data is put on chain, here's an example of some Bitcoin data that's been pushed to the Bitcoin price feed. So you've got rounds, which is basically just a number, and then the price, which is multiplied by 10 to the 8, I think, and then a timestamp, a couple of timestamps of when the round started and when it kind of was last updated. So yeah, the Chainlink data feeds contain full market coverage. So it's the price of the assets across the whole market at that point in time, not just from one exchange or from two, but from the whole market. So we use a mix of premium data providers and exchange data. The data is volume; it's aggregated based on volume, right, instead of time. And yeah, the feeds are live on multiple blockchains, and they've now been upgraded to use what we call OCR. So I just wanted to just mention this briefly because I think it's really cool. So OCR is basically where previously each individual answer was sent in its own transaction on chain, and the aggregation was done on chain. So in our example here, every single node in this list will be pushing an answer for each round. However, with OCR, what happens is the nodes talk to each other in this peer-to-peer network off chain, and they all submit answers and sign their answers, and then a single report is created that contains all of the answers. And then once all the nodes verify that everything's correct, that single report is pushed on chain by one node, and then everything's verified. So by doing this, it reduces gas costs by up to 90%. So the aggregation is still done on chain, so we still get all of the answers pushed on chain. It's just that it's done in one transaction only. So I'll just do a quick price feeds demo. I'm going to go to our docs at docs.chain.link. So this is just a quick demo of how to use one of these price feeds in your smart contract. So if I go to using data feeds, get the latest price, you can see that there's actually an example smart contract here, a Solidity smart contract. And we're going to actually press this button and it will open it up in the Remix IDE for us to play around in. So it's pretty simple. It's just a contract that uses this Chainlink library here, the aggregator v3 interface. And all we're doing is in our constructor, we're setting our price feed here to this address here. So this address is actually taken from in our using data feed section in the docs. If you go to contract addresses, it lists all the price feed addresses. So in our case, we're working on the Ethereum Coven testnet. So, oops, that's too big. So here it's actually the ETHUSD price here that we're using, I think. Yeah. And then once we set that, so we're saying, hey, we want to use the ETHUSD price feed on Coven. All we're doing in our function is just calling the .latest round data from that, and then that's returning a bunch of information, and then all we care about is the price, really. So if I compile that one, and we're going to deploy it on the Coven network. If I'm running a bit fast for you here, there's lots of great guides in our docs, which I'll show you before we finish up. So once it's deployed, if I hit that get latest price, hopefully you guys can see that. That's the current price of Ethereum in the price feeds running on the Coven network. So literally with a few lines of code, we're able to get high quality decentralized price data to use in our DeFi smart contract. cool. So specific to OCR, if anyone wants to do a deep technical dive into the computer science and, you know, security assumptions and things like that, highly recommend you to have a look at the white paper for OCR. So I'll just paste that in the chat as well. So definitely recommend checking that out if that interests you. So another example of you know, DeFi and hybrid smart contracts is using decentralized weather data to offer farmers crop insurance, right? So as you can see in this example, this is Arbol. It's a decentralized crop insurance provider live on Ethereum today. So the way it works is you have, you have data sources, you know, rainfall, temperature, etc. You have multiple Chainlink oracles pulling in data from these data sources. And then you have smart contracts that evaluate the insurance contracts, and they determine whether payouts, you know, need to occur, right? So this is an example of hybrid smart contracts again. And as you can see, it's very simplified. There's no claims process, right? So if the contract determines that the predefined conditions for the payout has been met, then the payout occurs instantly, right? And the farmer gets paid. Right? There's no agents that need to go out and do inspections. There's no claims that the client needs to submit. It's just, you know, bang, done. So, you know, with smart contracts, you know, the world doesn't need to wait for, you know, legal systems and infrastructure to provide services like this to people. Right? So this is a great example of the promise of hybrid smart contracts and cryptographic truth, and how it really can create a more fair, transparent, and efficient world. So in terms of DeFi and kind of its adoption, right now it's still very early days. In terms of the cryptocurrency space, the amount of crypto that's currently in use and locked up in DeFi, you know, people submitting crypto into DeFi protocols, it's less than 5%. We think over the years it's going to substantially raise, and it will probably come closer to the 50% mark. So probably close to 50% of the crypto market cap will be locked up in DeFi. That's what we think. So this is why we need to build these hyper reliable, hyper secure systems. We think there'll be a large influx of people wanting to get into crypto just to use DeFi, because, you know, for example, if you go on Aave, you can get something like 7% returns currently on a stable coin, right? So I don't know about Russian banks, but in Australia, you can't even get 1% here. So I think the only reason more people aren't on Aave yet is because they don't know about Aave. And I think this will also be accelerated by, you know, pending inflation and the continued systematic failure of, you know, these just trust us digital agreements that we have today. But if you go outside the blockchain world and you look at the remaining market for, you know, financial digital agreements, you can see it's, you know, still, we haven't even started yet, right? So it's unbelievably large. So, and to be specific, you know, this is where we believe the world is going, right? We want to go from this place where all these financial agreements operate using cryptographic truth, right? We want to go from this just trust us paper promises mess to a cryptographically guaranteed system of math-based truth where nobody can change anything unless it's been codified. This is why, you know, we have such a big focus on DeFi, and this is kind of what we're working towards. Okay, let's move on to API calls now. I'll just see how we're doing for time, about halfway. Any questions actually before we move on? Okay, cool. So hopefully now you've got a bit of an idea of what DeFi is and how Chainlink price feeds kind of help to enable DeFi. So let's move on to API calls. So as I stated earlier, a blockchain or a smart contract can't just make an API call on its own. So this is why you need an oracle. So Chainlink can actually be used to integrate to any API, whether it's a, you know, a web API or a web service to, you know, an enterprise database, an IoT sensor, etc. And the way it does this is with what we call the request and response model. So a consuming smart contract will do a request to an oracle and says, hey, I want to reach out to this API. And the oracle will take that request and it will fulfill the request, right? And it will then send the response back on chain, which will make its way back to that consuming contract. So that happens in a separate transaction. So it's not a synchronous, instantaneous thing like in the Web 2.0 world. It's usually a two-step process that happens over, you know, 2 or sometimes more blocks. So the way in which the Chainlink nodes achieve this is via the use of what are called adapters, right? So it's got what are called core adapters, and these are just standard adapters that provide the ability to call web services using HTTP GET and HTTP POST, you know, kind of web service calls, as well as various other tools for converting the data into the right format before posting it on chain. It's kind of out of the scope of this, so I just wanted to bring it up briefly. But if you wanted to reach out to something very bespoke and custom, like a database, you can create what's called an external adapter and then use that in your Chainlink node. So an external adapter is basically just a standardized API that has a specific structured input, and then a specifically structured output, right? So you can have whatever you want in the data section here, but you need an ID and you kind of need to have a job run ID here. And as long as your API adheres to that specification, you can then use that in your Chainlink node to connect to, you know, things such as databases, IoT sensors, etc. Things that you can't do with a normal HTTP GET or POST request. If you want to use Chainlink but you don't want to run your own node, there's something called the Chainlink market that you can go to, where people run their own node on various networks such as Ethereum, Binance Smart Chain, XDAI, etc. And you can search for jobs and nodes there. So here I'm on the Ethereum Cova network. If I want to do a HTTP GET and I want to get back a bytes 32 value or field, or a Boolean, you can kind of find a job here and you can get the information from here. So you can say, okay, I want to use this job ID in my node, in my smart contract, sorry. So rather than you having to run your own node. Obviously, you'd be aware that in a production scenario, you wouldn't want to just use one node for reasons I described earlier though. So in terms of use cases for API calls, one really cool one is using API calls to basically create what are called dynamic NFTs. So these are NFTs that have traits or metadata that can dynamically change, you know, based on certain external events. So here's a cool example of a sports NFT that dynamically changes based on real world data, performance data from, you know, a soccer player basically. So the soccer player scores a goal, wins a game, and then the Chainlink network can retrieve the player's stats off chain, and the NFT can then be upgraded to reflect, you know, player performance, making it dynamic. Cool. So let's do a demo of an API call. I'm just going to sign in again. So I was going to just use one of the nodes on the Chainlink market, but I thought I might try use my own node just so you guys can see the UI and stuff. So we're going to go back to the Chainlink docs at docs.chain.link, and we're going to go down to the using any API section, make a GET request. So there's an example smart contract here that we're going to open up in Remix once again. And in this case, it's a simple smart contract that basically just contains two functions and a constructor. So it contains a request volume data function that's going to perform the request for the API call. And then there's going to be a fulfill function that processes the response from the API call. So we're using the Chainlink client library, and all we're doing is we're calling this set public Chainlink token function, which just sets the address of the Chainlink token based on the network. So in this case, it's Coven, so we don't have to manually specify it. There's two fields here called Oracle and Job ID. So these are the two fields that depend on which node or Chainlink Oracle you want to use to process your request. So in our case, we're going to use my Chainlink node here. So I think this is the job ID we're going to use. And the Oracle contract, the Oracle address is this one here. So all our API call is doing is it's building up a request first. So we're creating this request and we're saying once our API call is successful, we want to call this fulfill function down here. And then other than that, we're just then appending things to our request. So we're saying we want to do a HTTP GET, and this is the API endpoint that we want to do that to. So if I just open it manually, you can see it's just a bunch of crypto data, and I think it's volume that we look at. Yep. So we're also adding a path parameter here. So we're saying once you do the API call and get a response, we want to traverse down this path to get a single value back. So raw.eth.usd.volume 24 hour. So that's this field here, I think. So that's the specific field we're looking for in our API call. And then once that's done, we're multiplying the result by 10 to the 18 because Solidity, as you probably know, can't handle floating point numbers. So we want to pad it out a bit to make sure we don't have any issues with arithmetic or anything. And then we're basically just calling the send Chainlink request to function, which will send the request to the Oracle contract, which our node will then pick up and process. So I'll try to compile that now. My Oracle contract is not right. Let's try again. Okay, so that's compiled. I'll now deploy that to the Kovan network. Cool. So once that's done, you'll see if I try execute the function to do the API call, I'm going to get an error. And that's because the fee has been specified as 0.1 link for this call. So what I need to do is I need to fund the contract with enough link so that when I do the API call, it has enough to then also send the correct amount of link to the Oracle contract to pay for the API call. So I'm sending 0.1 link to this consuming contract here. Once that's complete, I should be able to call the request volume data function. So here's my Chainlink node currently running. And as you can see, that's kind of the log. We can see a new run that was just created now. And as you can see, it's currently processing the request. It's actually got the data here. It's multiplying it by 10 to the 18 or whatever it was. And then it's converting it into a uint, and then it's sending the response back on chain. So once this is completed, which hopefully should be now, I should be able to go back, and if I press the volume button to see the value of this volume variable here, we can see that we have our volume here that's been padded out. So there's a simple example of doing an API call using Chainlink. Cool. Let's move on. We've got just over half an hour. So Chainlink is more than just price feeds and accessing external APIs. It also provides the ability to do off-chain computation. So doing computation on-chain isn't always ideal due to decentralization and gas costs and things like that, right? So it's not always very efficient. So one of the more pressing needs for off-chain computation was to implement a verifiable random number generator. So random numbers have been used for thousands of years, whether it's something like flipping a coin or rolling a dice. The goal is always to achieve an unpredictable outcome, right? So random number generators in a computer are similar. They're an attempt to achieve an unpredictable random result. Until now, getting random numbers on chain has kind of been a bit tricky because previously people were using a centralized oracle to get a source of randomness, which, as I explained earlier, is prone to being hacked and manipulated. Imagine if you had a lottery smart contract or something that uses a centralized oracle. That oracle can then directly influence the outcome of that lottery contract. And another thing that people were doing is they were using on-chain data for randomness as well. But as I explained earlier, the blockchain is deterministic, so that can actually be influenced as well, right? Determinism and random numbers don't really go well together. So what Chainlink VRF does is it provides a solution to generate provably random numbers. So this means that the on-chain contracts that request randomness can actually verify that the random number that they get was actually generated using the seed that they provided, right? So a seed is just a source of input for a random number generator. So the way it works is a smart contract will say to a Chainlink oracle, a VRF node, hey, I want a random number. Here's a seed. It's comprised of, maybe the public key of the Chainlink node, the hash of the block that contains a request, and probably a couple other things. And then the Chainlink node will then take that seed and it will basically generate a random number based on that seed, and then it will sign that message with its private key, and then send the response back. And then when that random number comes back on chain, there's actually a verification that happens. So the first thing it does is it verifies that the signed message came from the Chainlink node using the Chainlink node's public key, right? So that's just public-private key cryptography. And then the other thing it does, and this is where kind of the magic happens, is it verifies that the random number was created with the seed that was given in the initial request, right? And that it's not just some random number that, someone has specifically put in because they want to game the contract. It verifies that it actually came from the seed that was specified. So that's kind of the magic of VRF. So VRF allows for provably fair outcomes in things such as games. And there's a number of interesting use cases already in production. One popular one is minting NFTs with what are called provably random traits, right? So Avagotchi is a popular one here, where you can mint NFTs with certain traits that are provably random. Another great example here is using Pokemon booster packs here, and using VRF to provably assign provably random species and traits for the minted NFTs. So if you like doing things with NFTs, VRF and NFTs go really well together. And finally, another cool example of using VRF is in blockchain-based gaming. So gaming requires randomness in many cases. And as I explained earlier, randomness can't be achieved on-chain, really. So this is where having something like VRF can be used to kind of have a true source of randomness in your game logic. Cool, let's do a quick VRF demo. So I'm going to go back to the Chainlink docs at docs.chain.link, and there's a using randomness section here. So I'm going to go to the get a random number section. And once again, we have a simple example contract that we're going to just open in Remix. So the VRF consumer contract example is very similar to the API call one, in that it's a two-step process. There's a request and then there's a response function. So very similar, but there's a few things that we set that are slightly different though, which I'll go through. So once again, two functions, get random number and then fulfill randomness to kind of process the response. So in our constructor, we're setting a few things here. So we're manually setting the address of the link token for the network. We're setting the address of what's called a VRF coordinator contract. So this is a contract that sits on chain and sits in between smart contracts that want random numbers and do random number requests and VRF nodes. So it kind of sits in the middle and basically takes requests and then the node takes, the node looks at this coordinator contract and then processes requests, and then it will kind of pass responses back. So you can kind of think of it as an on-chain middleman type of contract. In addition to that, we're also setting the public key hash. This is the public key of the Chainlink VRF node that we're using, as well as the fee and link. So in terms of what do you set for these values, if you go to the Chainlink docs and go to contract addresses, depending on what network you're on, Polygon, Binance, Ethereum, etc., it's got the values in this kind of section here, in the VRF contracts section. So for Kovan here, that's the address of the link token. This is the address of the deployed VRF coordinator contract that everyone should use. This is the public key of the Chainlink VRF node that's processing requests, and the fee is 0.1 link. So that's where all those values come from. So all we're doing in the smart contract is we're checking to see that the contract is funded at first, and then we're calling this request randomness function that comes from our VRF consumer base library here, and we're passing in the key hash and the fee. And then that will get, then the Chainlink node will then pick up on that request from the VRF coordinator, and it will perform the request for randomness, and then it will send the response back, and we'll kind of get it here in this random result variable. So I'm just going to compile this one. Can ignore the warnings. So once that's deployed, once again, I need to fund it with enough link for the request. So on the Kovan network, it's 0.1 link that we need to pay. So I copy my deployed contract address. I go to my MetaMask wallet and I'm going to send 0.1 Kovan ETH. Cool. Once that's done, I can call my get randomness function. So now that's going to send the request. The VRF coordinator will pick it up. The VRF node will then pick it up from there. And we'll probably have to wait maybe 15 seconds on Kovan, and then we should have a response back. Try again. Should have responded by now. Let's have a look. So, oops. So this is our deployed contract on Kovan. So there was our get random number transaction request that got sent out, and there's been no incoming transaction. Oh, is this it here? Let's have a look. There we go. It was just a bit slow. Maybe a lot of people are using Kovan. So there's a random number. So it always comes back as this kind of large number. However, if you want to limit it to a specific range, you can perform a modulus function on it. So you can do a modulus of 100 to kind of get it between 0 and 100, etc. So you don't have to kind of always use this big number. You can kind of play around with the result and use it as you see fit. But the end result is always you have a provably random number that has been sent on chain that you can use as a source of randomness, right? And if you get a result back on chain, it means that the verification part has passed, right? If the verification fails and it verifies that it wasn't generated from the seed, or it wasn't signed properly by the VRF node, then you won't get this random number on your smart contract. Cool. Let's move on. So we've got 25 minutes. Let's talk about keepers now. So Chainlink Keepers is a relatively new solution that's come out recently as part of the Chainlink network. And basically what it is Keepers provides the ability to do off-chain compute, right? To offload off-chain compute to what we call a keeper network. And what this means is basically there are certain scenarios where you need to perform functions and do things with smart contracts, but smart contracts can't execute their own functions, right? They need to be manually executed by someone, right? So this smart contract here, I had to press the get random number function. I had to execute it myself to kind of run the function. So what Chainlink Keepers provides is the ability to kind of automate things like that and kind of offload it to a decentralized network so that you're not triggering it yourself in kind of this centralized manner, right? So the main use case we see it being applied to is to address this kind of centralization risk with using a single external system to perform DevOps operations on smart contracts. So for an example, let's say you have an insurance smart contract that checks the weather on a farm every hour and then determines if a payout needs to occur, right? So the smart contract's running on a blockchain. It's using a decentralized Oracle network to get data, but then who's calling that function to check the weather every hour at the location, right? Is it the insurance company? Is it the farmer? Is it, who is it? And what happens if that server or service that's running that function call, what happens if it goes down? What happens if they don't pay their bill, etc.? So the dev team would normally have a server or process that kind of reaches out and pings these contracts periodically. But this isn't ideal, as I explained earlier. So because when you're building decentralized systems, you need to be hyper reliable end to end, regardless of, when gas prices are really high or when servers go down. You need to make sure your system runs in all market conditions and all network conditions, because that's the nature of these blockchain-based systems, right? So you need to kind of maintain that cryptographic truth guarantee that under all circumstances, you'll be able to guarantee the outcome that the protocol says it will generate. And if you have a central server or system controlling and pushing and generating these contract interactions, you don't really have a decentralized protocol anymore. But if you use something like Chainlink Keepers, to kind of automate this and to kind of use this decentralized system that's crypto-economically motivated to do it for you, then you kind of can maintain that cryptographic truth. So what this does is it extends the security and reliability guarantees of a blockchain, and it extends it out to the off-chain compute part of the system as well. So Chainlink Keepers, they automate the triggering of smart contract functions and logic in a decentralized manner. You can define the exact set of conditions in which to trigger the execution of a function. So you can say every hour based on a certain event happening, etc. And we extend the properties of a blockchain out to the off-chain compute layer. So just a graphical visualization here is we have, some keeper nodes here. We have what's called a registry that has all of the smart contracts that want to have this kind of upkeeps done on them, so you might have a decentralized exchange and some other smart contract, and they'll say, I need to have this kind of work done based on these conditions, and they're stored in the registry here. And the way it works is on every block, the keepers check the registry for eligible upkeep. So they say, all right, which smart contracts that are registered here need to have work done to them right now? And some of them might say yes, some of them might say no. And there's a specific turn-taking algorithm to ensure that no one keeper is always performing upkeep on the same contract. So everything's kind of done in a proper order, I guess. And when a smart contract is eligible to have an upkeep done on it, it emits a payload to pass in to have the transaction performed. And then the keeper that's assigned to perform the upkeep for that smart contract will then basically perform that upkeep, and then the process continues, and in the next block, the keeper network looks for more eligible upkeeps. So just an example of using that in real world today is keepers for Aave. So Aave was the lending and borrowing DeFi protocol we saw earlier. And basically the way they use keepers is they manage the liquidations on their protocol. So when you're dealing with assets that can change in price quite frequently, and you're doing lending and borrowing based on them, obviously the DeFi protocol needs to know whether the loans are underwater or over water, right? They need to know if someone's submitted 1 ETH and they borrowed, 1 ETH or 0.8 ETH or whatever, if the price of ETH, or they borrowed, stable coins with that ETH, if the price of Ethereum goes down quite a bit, then their loan might be under collateralized, right? So the way that Aave uses keepers here is basically they register a Chainlink keeper job to trigger the liquidation function anytime a user's loan falls below their liquidation threshold, right? So the keepers constantly monitor the loan collateralization off chain and basically checks to see if they need to perform that liquidation or not. And the Aave smart contract will use a price feeds to determine is the loan under or over water, and if it's underwater and it's under collateralized, then the smart contract liquidation occurs. So that's just a simple example of using keepers in a DeFi protocol. Now we've got a bit of time, so I might just try to show you guys a real world example of that. So if you go to docs.chain.link again and you go to our keepers section, there once again we have an example contract that we're going to work with. So in this case, it's just a simple counter contract. So there's a public variable, an integer, and it's a counter, and then each time an upkeep is performed, we're incrementing that value. So the way that the keepers work is you need to have a check upkeep function defined, and this basically needs to return whether or not work needs to be done on your contract. So in our case, we're basically taking in an update interval in seconds and says every time this amount of seconds has elapsed, we need to perform upkeep, right? So we're comparing the current block timestamp to the last stored one, and if it's greater than, if more than the stored upkeep needed amount of time has passed, then we want to basically perform the upkeep. So when that happens, the perform upkeep function is called, and this is where you put your logic for whatever work needs to be done. So in our case, we're just updating the last timestamp and we're incrementing the counter. So very simple, and you just need to adhere to these two function specifications here, and that's kind of it for the smart contract part. So I'm going to deploy this to the Coven network once again. I don't know why it's asking for my password. Let's try again. All right, so we're going to deploy the counter contract, and we need to specify in our constructor how many seconds, what's the update interval. So I'm going to say every 30 seconds, I want to perform the upkeep task. So we're going to deploy that to Coven. Once that's done, you can see the counter is currently at 0. I'm going to copy the contract address, and then once you've deployed your contract, you need to register it for upkeep in the registry. So you need to say to the main registry that keeps all of the keeper jobs and say, hey, here's a new contract that I want to have work done to, and you can basically register it here. So we go register new upkeep. So we're going to put in an email address. upkeep name. Here's our deployed contract address. Gas limit 200,000 should be enough for the demo. I'll do a bit more. And a starting balance. So basically you're providing link to the registry to then be paid out to the Keeper network. So this is why they're crypto economically incentivized to do the work for you, right? So I'll start off by saying I'll put 15 link worth of funds into the upkeep job, and that should be enough to get it going for a little while anyway. Okay, so now we need a little bit more. So we've created our upkeep job, but it's saying that it's underfunded. So we put in 15, but it's saying that we need to have a minimum of 15.98. So what I'm going to do is I'm going to add another few link to it, and I'm going to approve that transaction. Now we'll just wait. Approve that. Cool, so that's done now. So now our upkeep has been registered. It has enough link to fund it for a while. And if we look at history here, we can see all the transactions that have been performed as a result of this upkeep. So the first one was we funded it with 15 link, then we added another 5. And as we can see now, there's already been one automatic perform upkeep. So if I go to my counter contract and check the counter variable, we can see it's been incremented to 1 because the perform upkeep function was called. And probably if I refreshed it again, there might be another one by now. Oh, not yet. So there's an example of using Chainlink keepers to do decentralized off-chain compute and kind of automate some of these smart contract function calls that you need to do as part of your protocol. Cool, let's close things off now by talking about where can you go to learn more. So the best place to go first is at docs.chain.link. This is where I was earlier for quite a bit for all the code examples. If you go there, we've got plenty of instructions on how to use Chainlink. We've got a good developer reference section, a good hackathon resources section as well. Another really good place to go is our blog at blog.chain.link. We're constantly adding new content there, especially developer focused content. So there's also some good high-end fundamental kind of articles as well, discussing some of the more technical aspects of some of the Chainlink solutions. If you're more of a video person instead of text, you can go to our official YouTube channel. We've got a really good playlist called Chainlink Engineering Tutorials that you can check out, where you can learn how to spin up your own Chainlink node, how to create a dynamic NFT using Chainlink, all these kinds of various topics. We have what we call our starter kits as well. So if you go to our repository on GitHub at github.com smart contract kit, you'll see we have Hard Hat starter kit, Truffle starter kit, and Chainlink mix. These are boilerplate projects based on popular Ethereum or EVM development IDEs. So Hard Hat, Truffle, and Brownie. And they're pre-packaged projects that contain smart contracts that use Chainlink solutions. So all of the example contracts you saw today that I ran, they're contained in these starter kits as well, in this pre-packaged repository where they also have all the scripts and deployments and things and tests, and it's all kind of pre-packaged together so you can easily spin up examples of smart contracts using Chainlink. So definitely recommend checking those out. And yes, so we have a hackathon underway as well. I highly encourage everyone to sign up and participate, no matter your experience level, no matter your skill level. This is one of the biggest hackathons yet, actually. I think there's something like 400 $100,000 US in prizes. And there's specific tracks for beginners as well. So if your experience level is not as high as if you're more of a beginner, if you think, you could still enter and team up with others, and we definitely encourage it. So if you head to hack.chain.link, you can find out more information and sign up there. So yeah, definitely recommend checking that out. Hackathons, if you want to get a job in blockchain and crypto, hackathons are a great way to get your name out there and get noticed. And also, we recently released a new white paper that outlines a new architecture for building hybrid smart contracts. And we discuss other topics such as crypto economic staking, scaling, confidentiality, etc. So if kind of this research, if research really and kind of high level solutions really interest you, definitely recommend checking this out. Thanks for posting the link in the chat, Tatiana. And we also have other research papers available on our Chainlink Labs website here. I just posted it in the chat. So if you go there, you can see we've got the old white paper there, the OCR white paper, as well as white papers on town crier, mixicals, and deco. So definitely recommend checking that out if that's your kind of thing. And yeah, if you have any questions, if you want to reach out, we recommend the best place to probably reach out to us is in our Discord at chain.link/Discord. We'd love to interact with you guys there, especially if you're building a project, as like whether you want it to go to mainnet or if it's part of your course that you're doing or anything. We'd love to interact and help everyone there. And yeah, finally, if this kind of thing interests you, whether you're still doing your course or finishing, or when you do finish, we encourage you to reach out to us if you feel this is the kind of thing that you'd like to do, because we currently have lots of open roles, full-time, part-time, and yeah, we encourage people to apply. Cool, that's all I had to discuss. And I think we've got just a few more minutes if there's any questions.
Harry, yes, there are two questions from Alexei. One is about dynamic NFTs, and another one is a bit more generic about smart contracts. Where do you want to begin, with dynamic NFTs or?
Sure.
Okay, so Alexei asks, you gave that example about a football player and how it turns into a dynamic NFT. And technically speaking, how much more complex it is to deploy dynamic NFTs as opposed to the regular ones, and which technical additions, applications, or other things technical required for dynamic NFTs?
Yeah, okay. So in terms of the underlying structure, the NFT is still just an NFT in the end. It's just that the traits or the metadata that is stored against the NFT get updated by a smart contract, by external process, by whatever means necessary. So it's definitely more complex than a normal one, because it's kind of like a living thing. It's not just a deploy it and then it stays the same, for forever. But it's not hugely complex, and we've actually got some really good blog posts on this that I'll paste in the chat as well, that I recommend checking out. And that one, yeah, have a look at those, and you'll kind of get a bit of a feel for it. But yeah, hopefully that answers the question a little bit.
Thank you very much, Harry. And the question about smart contracts also from Alexei was about, so he mentions that media talks a lot about errors made in smart contracts when they are created. And that obviously poses a risk for end users in DeFi. So there is a big conversation going on in Russia about that. And when do you think this problem can be resolved, and why it exists to begin with?
Yeah. Okay. Yeah, smart contracts are kind of very unique and tricky because they're these immutable things, or they're meant to be immutable, and they often control funds as well, movement of funds. So when you combine the two things, you kind of get into a scenario where if people don't create these things securely and then they get deployed, then they can kind of be exploited, and people will look to exploit them because they have funds in them, right? So that there was, some recent exploits where, $600 million worth of funds were taken and things like that. So it's a tricky thing because you've got something that's immutable, and then you have, and it controls funds. It creates a scenario where, people will try to exploit it. And in terms of how to kind of solve it, I think, DeFi is still very early. And unfortunately, the nature of open source projects is that anyone can kind of fork a protocol and, deploy it on their own, and then, get traction, and, people can end up using it. But I think as time goes on, tools are getting better for creating more secure protocols. And hopefully people are learning lessons from the past as well. But it's a very tricky one because there's new exploits and things that happen all the time. And there's ones that sometimes they're ones that we don't even know about, right? So there might be an exploit that happens in, 2, 3, 10 years time that we would never have seen coming. And after it happens, we know how to protect against it. But then before it happens, we don't know what we don't know. So, I'm hoping as time goes on, we kind of continue to do the right things and learn from the lessons of the past and try to build them as securely as possible.
Thank you. And I'm looking at the comments that are coming in from YouTube, and Dawn is saying, I'm enjoying this Chainlink presentation. It's very informative. Chainlink's grand vision for a global transition to a world governed by cryptographic truth is happening, and it is wonderful. So people are really enjoying your presentation, and Azamat and lots of other folks are saying the same. So thank you so much for your presentation. And I don't see other questions. If anyone has any questions, please let us know now, or we'll let Harry go. He's in Australia. It's in the middle of the night where he is now.
That's all right. I was very, very honored to be able to speak and at such a, well-regarded, university. So I'm very happy.
Thank you so much. Thank you so much for your time, Harry, and for sharing that information. And hope to see you soon with MIPT and other Russian universities and developers. Thank you so much for your time and for your presentation. And thank you for everyone who attended. Thank you.
Cool. Thanks everyone.
Thank you. Bye.
Bye-bye.
Bye.